Hello. Today we consider the modern problems of emergency logistic planning by the fuzzy modeling instruments and tools for disaster-stricken zones. For a presentation plan, we consider the basic general directions of research in this environment to emergency logistic planning for stricken zones. In our optimization models or such as planning, we always issue assumption of fuzzing emergency logistic models. We usually consider several basic or main facilities of emergency logistic planning, such as humanitarian aid distribution centers, temporary logistic hubs, shelters. In future, we create a more detailed and deep detailized general model with respect to shelters and victims evacuation from affected areas to the shelters as a multi-objective fuzzy emergency logistic planning optimization model. We create some multi-attribute decision-making models for the evaluation of feasible selection location of facilities for the opening for the servicing from these points to the demand points. We usually present and approximate numerical solutions of our created models, and we always create demo versions of software development of our models for the presentation, our basic results dealing with such as problems. We always work for the response phase of the emergency logistic planning. So we create some creative mathematical models of emergency management planning. And we always create demo versions of multi-objective emergency logistic planning. We have a good experience with long history with Georgian firms, the Georgian business directions, which have a long time history of distribution network of their products to the distribution networks. We have good experience with Georgian EMA, Georgian Emergency Management Agency, and the dispatchers or experts of this emergency management agency always help us by the evaluation of input data for our problems modeling, and always consider the experience and the knowledge as a necessary part of our future work is investigation of such as problems. We have good collaborative experience with foreign groups of artificial intelligence which works in such as our problems. We have several projects as a grants dealing with these problems, as in Georgian National Scientific Foundation or other foundation centers. We consider as a shelters case, briefly consider the basic instruments for the creation of our multi-objective emergency emergency logistic planning problem. We consider multi-attribute decision-making problem dealing with the evaluation of feasibility levels of opening facility centers in our models. Let me give us some sets of attributes which act on the opening opening of facility locations or distribution centers. And these attributes may be the following as an ability of conform or sustainable, create regulation imposed by emergency managers after disasters, ability to increase the size to accommodate growing demands and out. These attributes will be used in our multi-attribute decision-making model, where in the role of possible alternatives, we always consider possible distribution centers in our multi-attribute, multi-objective optimization problem. So at the ending of this multi-attribute decision-making problem, we evaluate by created aggregation operators or aggregation tools, levels of feasibility or reliability, or such as candidate distribution centers. With these reliability indexes will be used in our future new type objective functions in multi-objective optimization problem. For example, we consider general fuzzy model for the disaster-stricken zone by the evacuation of population from the affected areas to the shelters, and the opening problem of shelters, open location allocation problems of shelters opening in such as models. We have several indexes of affected areas or candidate shelters, indexes of aerial vehicles and the terrestrial vehicles. We have some parameters dealing with distances between affected areas and candidate shelters. And we have capacities of candidate shelters, numbers of victims in affected areas approximated, evaluated in triangular fuzzy numbers or other fuzzy values, fixed cost of 4 open and 4 concrete shelters, selection reliability indexes which were presented in the previous slides, minimal acceptable distance which is necessary for the evacuation from the affected area to some shelters, degrees of impossibility of vehicle movement between affected area to the concrete shelter, which will be in our models will be evaluated by the possibility simulation, Monte Carlo simulation, as interactive procedure with the concrete dispatchers, which has information about images and problems on the network, with networks, roads, and based on this, on dispatchers' knowledge, we will evaluate degrees of impossibilities of vehicle movements on networks of these roads. We have capacity of vehicle, number of vehicle for evacuation processes, some constants which is necessary for the normalization of as a constraints as a objective functions. We have 3 decision variables, X decision variable, which is indicates on the openings, some shelters, Y decision variable, which indicates of the transportation type and evacuation from some affected area to the concrete shelters. Z variable, which indicates of the victims number from the some area to the concrete shelter. We have 4 in our models. We have 4 objective functions. 4 functions deal with the reliability indexes of opening shelters, which aggregates individual reliability indexes of shelters. Objective 2 deals with the total cost, which is necessary for the for the evacuation of victims from the affected areas to the shelters. Objective 3 indicates on the total fuzzy time for the evacuation processes, which is based on the distances between the affected areas, on the numbers of victims from which will be evacuated from affected areas to the victims, to the shelters, the number of vehicles, the capacity, and so on. Also on the impossibility levels of impossibility degrees of vehicle movement between affected areas. So this is new type objective functions, practically defined by the generalization of so-called Choquet integral. And the objective function 4, which minimize number of shelters. We have several constraints, which is presented by the several inequalities, and sometimes we consider so-called chance constraint of possibility multi-objective problem instead of fuzzy multi-objective optimization problem. And now briefly on the solution directions of our constructed models. So in our problems, we always recognize Pareto optimal sets, Pareto problems of optimization problems. We always use goal programming extensions for the fuzzy cases, and also epsilon constraint methods. Also fuzzy machine learning directions, deep machine learning directions, or fuzzy variants for our problems. Thank you very much for your attention.